The following information is brought to you from the National Climate Report for February 2021.
From February 10th to February 19th of 2021, an unprecedented winter storm struck the northwest, central, and eastern portions of the United States. Texas and Nevada specifically were hit by this incident, dropping an unprecedented 40 degrees. These states, both in their architecture and the people themselves, were not prepared for these below freezing temperatures. Power outages resulted from a lack of the preparedness, leaving as many as 10 million people without power during the storm's height. Below freezing temperatures also caused the unprepared water pipes to burst once thawed, causing significant structural damages. This weather remained until February 19, 2021, and is known as the Winter Storm of 2021. This not only caused $20.8 billion worth of damages, but resulted in the deaths of 172 unsuspecting victims. While the meteorological event could not have been mitigated, some of the damages associated with it could have been by observing past weather phenomena and figuring out whether this extreme weather could have been expected. That way, we could be prepared for the worst, no matter how unlikely. According to statistics, once again, brought to us from the NOAA, since 2001, so in the past 20 years, 7 of these severe winter storms have occurred. The number doesn't seem to be increasing or decreasing, but seems to be rather consistent, aside from this gap between 2001 and 2009. However, if you look further into the history, so you see there is a gap. However, if you look back further than 20 years, you will see that this does seem to be consistent, the amount of storms between 2010 and 2021. The lull here is the outlier. So in the past 20 years, there have been 7 of these winter storms. And as we can see, the one in 21 did take the largest financial toll out of any of them. While this event was the worst in recent years, it's not the only time this sort of winter storm has hit America. Over the past 20 years, these sort of winter storms have cumulatively cost the United States $33.5 billion worth of damage and resulted in the deaths of 288 people. To understand the meteorological event behind this disaster, you must first understand the concept of what an air mass is and the role that it played during this February storm of 2021. On page 78 of the 15th volume of the textbook Earth Science, authored by Edward Tarbuck, he defines an air mass as an immense body of air, usually between 1,600 kilometers or 1,000 miles or more across, perhaps several kilometers thick, which is characterized by a similarity of pressure and moisture across a given altitude. The air mass in question specifically would be a continental Arctic air mass, which would be located right around here. This is where it would form. This is characterized, again, by Tarbuck as a cold, dry air mass that is carried southward. So this is where the air mass originally formed, and it came all the way down here to affect these portions of the United States. The reason this air mass specifically was brought down so far south and hovered over the United States for so long was because of an intensely negative Arctic oscillation. This is defined by Rebecca Lindsay, a managing editor and contractor to the NOAA Climate Program Office, as a back and forth shifting of atmospheric pressure between the Arctic and the mid-latitudes of the North Pacific and North Atlantic. Basically, this means that the air pressure of this air mass, the Arctic continental air mass, and the surrounding air masses flip-flops between positive and negative. So here we have the positive phase, wherein this is a negative surrounded by positive air masses. The negative phase, pictured on the left, is characterized by positive air pressure and is surrounded by negative air pressure. During February of 2021, when this winter storm occurred, we were in the negative phase. The reason the negative phase has problems for us is because the jet stream meanders way further south than it normally would. Remember, positive here, surrounded by negative air pressure. In the positive phase, this high air pressure surrounding the Arctic region keeps the jet stream further north. It doesn't let it meander as much. The negative phase allows the jet stream to veer southward towards the equator, as we can see, much further south than here. So when the jet stream dips like this towards the equator, what it does is it brings all this intensely cold Arctic air down, even further down than what is pictured here. So that's what's happening right here. The jet stream, because of this intensely negative Arctic oscillation, has meandered way down here, maybe even further down. That brings all this air mass down here. All this cold, this intensely cold, bitter Arctic air down. That's what caused the 40-degree pressure drop in places like Texas and all these southern states. I apologize for the drawing. It's important to keep in mind that this negative Arctic oscillation, bringing this intensely cold Arctic air mass down, can be brought on by a warmer Arctic region, which, as stated by Lindsay in the article I've been mentioning throughout. She states that the negative phase allows the jet stream to veer southward towards the equator, bringing this Arctic continental air mass with it. And Lindsay also points out an important point regarding this oscillation, this negative oscillation. She states that the negative Arctic oscillation favors a warm Arctic and cool conditions around the US and Europe, meaning that this here, when it's warmer, has a higher tendency to have a negative Arctic oscillation. So it's not out of the question to consider that climate change could have increased the likelihood of this negative oscillation, bringing the jet stream down, bringing the air mass down, all those cold temperatures.
I say that climate change did play a significant role in this natural disaster because the warming of the Arctic is directly linked with an increase of winter weather severity. According to a study conducted by Jennifer A. Francis and Stefan J. Varas, both top scientists in climate research, enhanced Arctic warming relative to that in the mid-latitudes may cause more persistent weather patterns in the mid-latitudes. So strongly negative Arctic oscillation occurs when the Arctic region is warmer than typical, according to Lindsay, as we've previously stated. The NOAA and National Center for Environmental Information released an article elaborating on this phenomena, stating that a greater prevalence of high-pressure blocking patterns over the North Atlantic that result in cold outbreaks in the eastern United States along slower-moving systems can further exacerbate the persistence and severity of the storm. Simply put, climate change increases the temperature of the Arctic region and, in doing so, creates a favorable environment for an Arctic air mass to move more slowly, move more southward towards the equator, and linger over the United States for longer, as opposed to heading east due to a difference in pressure. Even while climate change has affected the severity of this billion-dollar disaster, it is the only clearly visible human cause to do so. Even if it wasn't the only factor leading to this disaster, climate change did play a significant role in its formation and exacerbation, which cannot be overlooked. Taking steps to reverse the damage done to our atmosphere could potentially lower the risk of more negative Arctic oscillations occurring. Many of the tragedies associated with this winter storm, being financial loss and most importantly loss of life, could have been prevented if southern states had invested in warning systems for citizens as well as better infrastructure capable of withstanding colder temperatures, even if these states seldom reach such lows, so that when the time comes that the temperatures drop, the outcome is not so catastrophic. Thank you for listening.